In Chapter 9, we're going to start with geometry and the coordinate plane. So in Section 9.1, we're going to talk about perimeter and area in the coordinate plane. On page 545, you do have two vocab words in your gray region. But everything there with the key concept in your vocab words, I want you to look over it, but I'm not going over it on the video as it's all review from elementary school. What perimeter is, what area is, and certain formulas for different types of polygons. So it is review, but I do want you to look over it quickly before we go on. So we're going to start with problem 1 under the got it. Problem 1 says that we're going to find perimeter and area of a rectangle in the coordinate plane. So I've drawn my coordinate plane, and it says we have a rectangle with the vertices h, I, j, and k. What is the perimeter of this rectangle, and what is the area of the rectangle? So the first thing you're going to do is just graph all the points. So h is at -5, -3. I is at -5, 2. J is at 2, 2. And K is at 2, -3. This should be incredibly easy since we're taking elementary concepts here. We know that the length of the sides are both 5 units. The bottom and top are all 7. So the perimeter would be adding them up. 7 plus 7 plus 5 plus 5. That'd be 14 plus 10. That is 24 units. And if there is no label given, we are going to use the generic term of units. The area is taking base times height. 7 times 5 would be 35, and our label always has to be squared, so it would be 35 square units. That's it. There is problem 1. At the top of page 547, it says that we can name a circle with a symbol, and it shows the symbol. For example, the circle with center A can be written as circle A. The formulas for a circle involve the special number pi. Pi is the ratio of any circle's circumference to its diameter. Pi is an irrational number, and you can see what pi is. For approximating an answer, you can use 3.14 or 22/7 for pi. So we're going to start with the got it problem, A and B, under problem 2, finding circumference of a circle. So A, what is the circumference of a circle with radius 24 in terms of pi? Well, the circumference formula of a circle is 2 pi r, or pi times d. 2 times pi times the radius, which is 24. Now, when it says in terms of pi, that means we do not plug in the value of pi. We leave pi as pi. So your circumference in terms of pi is 48 pi. That's it. B is doing the exact same thing, except we want to know our answer to the nearest tenth. So we want to use the circumference given a diameter of 10. Well, if we have a diameter of 10, we're going to use circumference is pi times d. Diameter is 24. So 24 times 3.14 rounded to the nearest tenth gives us 75 4/10. And we do not have a label. So we're going to put units, and we're going to put units in actually both of these. In problem 3, we're going to be finding perimeter and area of a triangle in the coordinate plane. So as in the got it, it says triangle ABC has vertices ABC. We'll find the area and perimeter. So I'm going to graph all 3 of these. So we graph -6, 4. That's A, and I'm going to graph the other 2. So if we find the perimeter, we find the perimeter of all the sides. 1, 2, 3. This is 3. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12. Now, to find from C to B, you have 2 options. You can either use Pythagorean theorem, or you can use the distance formula. I'm just going to use Pythagorean theorem. 3 squared plus 12 squared equals c squared. That gives you 9 plus 144 equals c squared. That means c squared is approximately 153. We take the square root and round to the nearest tenth. So then you take the square root of 153 and you get 12.4. So the hypotenuse is 12.4. So now we just add them all together to find the perimeter. 12 plus 3 is 15, plus 12.4 is approximately 27.4, and you would say units. The area is base times height. The base and height always have to be perpendicular. So our base and height are 12 and 3. So our formula is 1/2 base times height. So 12 times 3 is 36, and half of 36 is 18. And we would have units squared as the area of the triangle. In problem 4, we're going to find the perimeter of a pentagon in a coordinate plane. So I've already graphed this shape as you see in your book. All we want to do is to find the perimeter. So the perimeter, 1, 2, 3, 4, 5. This would be 5. 1, 2, 3, 4, 5, 6. This is 6 units. 1, 2, 3, 4, 5. This is 5 units. We now have to find this length and this length. So in order to find the length, we're going to use the distance formula. And remember, the distance formula is when you take the square root, you subtract your x's, so we could take -2 minus 1, square it, plus your y's squared. So that gives us -2 minus 1, that's -3 squared, plus 4 squared. That gives us 9 plus 16, and that gives us the square root of 25, which is 5. So we know this length here is 5. Now the other side is going to be the same thing because this is symmetric, so we know n to j is also going to give us 5. So we add up all the sides, 5 plus 5 plus 5 plus 5. Well, that would be 20 plus 6, and our perimeter would be 26 units. On page 550, problem 5 is finding the area of the circle. In the got it problem, we have to find 2 parts, knowing that the diameter of a circle is 14 feet. So we know the area of a circle in part A. It says find the area in terms of pi. We know the formula is pi r squared. So if we plug that in terms of pi, that means we leave pi alone. And the radius, if the diameter is 14, the radius is 7. So we're going to plug that in, and we get 7 squared, which would be 49 pi units squared. B is actually using the approximation of pi. So we take the exact same answer, 49 pi, and we can just plug in 3.14. And 49 times 3.14 gives us approximately 150, either 3.9 or we could round to 154. It's up to you because it does not say what's a round to. And the area would be units squared. So this answer is leaving in terms of pi. This one is plugging in the value of pi. Problem 6 is when you find the area of an irregular shape. An irregular shape means you have multiple shapes put together to make one irregular shape. As you've done in the past, all you do is split it up. So in got it problem B, we want to find the area. I'm just going to cut it up into a rectangle and a triangle. So the rectangle will be 12 times 4. That gives me 48 squared feet. Well, in order to find the base and the height of the triangle, we know that we have tick marks here, which means they're the same thing. So this is going to be 4. This is going to be 4, which means this length has to be 12 minus 4. So that gives me 8. So I take 1/2, base times height. Well, 8 times 4 is 32. And 1/2 of 32 is 16 squared feet. So my total area would be 48 plus 16. That would give me 64 squared feet. And then the last problem, number 11, is also an irregular shape, but it's when you have a hollowed out part of this. You can still separate this into different shapes. But the easiest thing that I find is that when you have a piece missing, you take the area of the entire shape, take the area of the hollow shape, and then subtract them. Since the big shape is a rectangle, we can take 8 times 12. 8 times 12 gives us 96 squared inches. The inside square is 4 by 4, so that's 4 times 4. That gives me 16 square inches. But this is the piece that's missing from this. So I subtract 96 minus 16, and that gives me an area of 80 squared inches. And the only vocab you learn from this chapter is area and perimeter. You do not need to put that in your vocab bank because those are review vocab words from elementary school that I expect you to already know.